Guys, welcome to my channel. My name is Aditya Anjan Jha and my USN is 1E22CS006. Today we'll be talking about regular expression. Abstract regular expressions are commonly used but often difficult to understand and reuse, primarily due to the complexity and lack of abstraction, leading to large and confusing expressions. This challenge is exacerbated by issues of viscosity, redundancy, and terseness in their notation, resulting in many incorrect versions of similar problems, complicating their effective use in software development. To address this, we propose a range of independent and complementary representations that serve as explanation for regular expressions, alongside methods for computing these representations. Our approach not only enhances understanding but also aids in identifying faults in regular expressions, demonstrating significant potential to improve software engineering practices through wider applicability and usability. Introduction. Regular expressions serve as a powerful meta language for describing various textual formats, protocols, and languages originating from formal language theory and commonly used in applications like compilers, network analysis, and even fields outside computer science, such as sociology and biology. Despite the widespread use, regular expressions present significant challenges. Their complexity makes them hard to understand. Many expressions contain subtle errors, and a proliferation of similar versions complicates the selection of the appropriate expression for specific tasks. This lack of abstraction contributes to the growth of overly complex expressions, making them difficult to interpret and verify, as evidenced by the prevalence of questions related to regular expressions on platforms like Stack Overflow. To mitigate these issues, we propose a set of methods designed to explain regular expressions, revealing their structure and intent, aiding user understanding, enhancing repository searches, and identifying bugs, thus addressing the inherent difficulties in their use. Methodology. Deficiencies of regular expressions. In the following, we point out some of the major shortcomings of regular expressions. Lack of abstraction. A major deficiency of a regular expression is the lack of an abstraction mechanism, which causes, in particular, the following problems: scalability, lack of structure, redundancy, unclear intent. Inability to exploit domain knowledge. Abstract conceptual domains are structured through metaphorical mappings from domains grounded directly in experience. The abstract concepts are easier to pick up if users are provided with a mapping to a less abstract or more familiar domain. One of the difficulties with regular expression is that it is a formal notation without a close mapping to the domain that the user wants to work with, which makes it difficult for new users to pick up the notation. Role expressiveness. A role expressive notational system must provide distinctive visual cues to its user as to the function of its components. Plain regular expressions have very few beacons to help the user identify the portions of regular expressions that match the relevant sections of input strings. The users typically work around this by using sub-expressions that correspond to major sections in the input, and by using the indentation to indicate roles of sub-expressions visuals. Error proneness. Regular expressions are extremely prone to errors due to the fact that there is no clear demarcation between the portions of regular expressions that are shared between the alternatives and those portions that are not, and thus have a higher contribution towards the variations that can be matched. Results. The different explanation representations explored so far serve different purposes and each help explain a different aspect of a regular expression. Ultimately, all the different representations should work together to provide maximal explanatory benefit. To some degree, this cooperation between the explanation is a question of GUI design, which is beyond the scope of the current paper. We therefore employ here the simple strategy of listing the different explanations together with the regular expression to be explained. We add one additional representational feature, namely the color coding of identified sub-expressions. This enhances the explanation since it allows us to link sub-expressions and their definitions to their occurrence in the regular expression. As an example, consider the explanation of the embedded image regular expression. For colored nested definitions, we employ a simple visualization rule with reference to the containing colors. This leaves us with non-nested colors. This rule can be in action where the occurrence of the colors sub-expression 29 days as part of the expression representing 30 days and 31 days in the non-color coded in the original regular expression. Discussion. These are the two graphs showing the frequency of sub-expressions and the degree of sharing. Conclusion. We have identified several representations that can serve as explanations for regular expressions together with algorithms to automatically or semi-automatically in the case of intention analysis reduce these representations for given regular expressions. By comparing raw regular expressions with the annotated versions that contain decomposition structures, formats, and intentional interpretations, it is obvious even without a user study that our methods improve the understanding of regular expressions. The use of the developed explanation structures is not limited to explain individual regular expressions. They can help with finding regular expressions in repository and identifying errors in the regular expressions. This demonstrates that explanation structures are not simply comments that one might look as if needed, although even that alone would be a worthwhile use, but that they can play an active role in several different ways to support the work with regular expressions. Our evaluation shows that the method are widely applicable in practice. The limitation of regular expression have proved that several designs for improved languages. However, it does not seem that they will be replaced by the regular expression representation anytime soon. Therefore, since regular expressions are here to stay and any support needed, help with their use and maintenance should be welcome. The explanation, structures, and algorithm developed in this paper are a contribution to this end. So, thank you for watching my video. See you in the next one.